In this video, I will show you how to determine if a triangle is isosceles, scalene, or equilateral. First of all, please remember that an equilateral triangle has 3 equal sides. An isosceles triangle has 2 equal sides. So what's left? A scalene triangle has no equal sides. So basically my strategy is going to be to find the lengths of all 3 sides. So basically I need to find the length of side AB. And by the way, if I just write AB like this, it means the length of side AB automatically. So I need to find the length of side AB. I'm going to find the length of side BC. And I'm going to find the length of side AC. Now, the easiest way to find these lengths is to use the Pythagorean Theorem. So, for example, if I want to find the length of side AB, I will make a little right triangle out of it by giving it a horizontal piece and a vertical piece, which makes AB the hypotenuse. Maybe I'll try to draw that as well. Okay, so the little horizontal piece here is 1. The vertical piece, 1, 2, 3, 4, 5, 6, 7. So here's where the Pythagorean theorem comes in. I'm looking for the hypotenuse. So that's going to be c. So a squared plus b squared equals c squared. So that's what I'm about to do. So 1 squared plus 7 squared is equal to the hypotenuse squared. Well, that's 1 plus 49 is equal to the hypotenuse squared. So that's 50. All right, so to get c by itself, I need to actually take the square root of both sides. So that tells me that c is the square root of 50. All right, in other words, the length of side AB is the square root of 50. All right, so I just need to do that 2 more times. I think I'm going to erase this to just keep the picture neat. So now, look at side BC. So I'm going to make a triangle out of that. So look at, here's BC. Boom, boom. And this is the hypotenuse. Okay, so this is 5. And this is also 5. So, again, if I want to find the hypotenuse, I can just do the Pythagorean theorem. So that's going to be 5 squared plus 5 squared is equal to c squared. So that's 25 plus 25 is equal to c squared. So that's 50 is equal to c squared. So if I take the square root of both sides, that is going to be the square root of 50 again. So again, I have the square root of 50. Okay, so now I'm going to find the length of side AC. So again, let me erase all this to keep it neat and clean. So I could make a right triangle like this. All right, here's a right triangle that has AC as the hypotenuse. So this side on the left is 2. And this side right here is 6. So I've got 2 and 6. I'm looking for the hypotenuse. So again, a squared plus b squared equals c squared. So that means 2 squared plus 6 squared is equal to c squared. So that's going to be 4 plus 36 is equal to c squared. So that means 40 is equal to c squared. So taking the square root of both sides, that's going to be the square root of 40. So these are the 3 lengths. So notice that I have 2 sides that are equal. All right, AB and BC are the same length. And if I have 2 equal sides, that is an isosceles triangle. All right, so that's why the answer to number 5 is isosceles. All right, now I'm going to show you how to determine whether or not this triangle is a right triangle. Being a right triangle means that one of these angles would have to be a right angle, a 90-degree angle. So this has nothing to do with the length of the sides. So I'm not going to find the lengths like I did before. Actually, what I'm going to use is the slope, and I'm going to tell you why. A long time ago, we learned about the slopes of parallel lines. All right, for example, parallel lines. All right, imagine I had 2 lines, line 1 and line 2. If line 1 had a slope of 5, and line 2 is a parallel line, what would be the slope of the second line? It would also be 5. Because parallel lines have the same slope. So if I ever see 2 lines that have the same slope, I know they're parallel. Now, on the other hand, what about perpendicular? All right, let's talk about perpendicular lines. If one line, again, let's say it had a slope of 5. If the second line is perpendicular, what will be the slope of a perpendicular line? Well, there were 2 words that we always use to describe the slopes of perpendicular lines: opposite and reciprocal. Okay, let's actually start with reciprocal. Reciprocal means you turn it upside down. So for example, if I had 2/3, the reciprocal would be 3/2. That's what reciprocal means. But what's the reciprocal of 5? Well, 5 is sort of like 5/1. All right, I could kind of put a little 1 under here. So the reciprocal would be 1/5. All right, that takes care of the reciprocal part. What about opposite? What does that mean? That means opposite in sign. So if the first slope is positive, then the second slope would be negative. All right, now these are opposite and reciprocal, so these are the slopes of perpendicular lines. Now, what does this have to do with proving that a triangle is a right triangle? Well, if you have a right triangle, that means you have a 90-degree angle. And if you have a 90-degree angle, guess what? That means you have perpendicular lines. So an easy way to prove that a triangle is a right triangle is to find all of the slopes and look to see, do you have any slopes that are opposite and reciprocal, like 5/1 and -1/5. If any of the slopes are opposite and reciprocal, that means you have perpendicular lines. And if you have perpendicular lines, that means you're looking at a 90-degree angle, which means you have a right triangle. So that's the theory behind what we're doing. Now let me erase all this and let's do it. Let's do it. Double down. Okay, finding the slope is a lot easier than finding the length. So I need to find the slope of okay, DE. All right, in fact, I'm just going to say slope DE. I need to find the slope of EF. And I need to find the slope of FD. Now, slope is just rise over run. So if I want to find the slope of DE, all I need to do is draw the rise and the run. Okay? The rise is, let's see, 7. The rise is 7. The run is 2. Okay? So the slope is 7 over 2. Rise over run. When you think you have the slope correct, always look back and check the line you're talking about. If it's uphill, it should be a positive slope. If it's downhill, it should be a negative slope. So from left to right, this is uphill. So I'm going to definitely make sure this is a positive slope. So let's move on to slope EF. Okay, so here's E, here's F. I need a rise and a run, vertical and horizontal. Okay, this has a distance of 3. All right, I could call it -3, but for right now, I'll just put 3. So that means I'm going to have a 3 in the numerator. Then I have a run of, what is this? So it's 5 and 4. So that looks like 9. That's a run of 9. I will reduce this in a moment. So I have a rise of 3 and a run of 9. Is this slope positive or negative, guys? Okay, from left to right, can you see that this is going downhill? That makes this a negative slope. So make sure that you put negative. Some students like to pick up this negative by thinking I'm going down 3 and right 9. So they'll put -3 and +9 because of that. All right, I just like to do the numbers and then go, oh, downhill, negative. Let's go ahead and reduce this though. This will reduce down to -1/3. Okay, and finally, let's calculate the slope of FD. Okay, so let's see, FD. So rise and run. So here's the rise. Okay, that was a crooked line, but you're just going to forgive me. And here's the run. Oh, that's, whoa, whoa. Looks like a heartbeat. Why is that so crooked? I'm not redoing it. I don't care. So this is 5. And this is, let's see. It was 5 to the left. Wait, is this 5? No. It's 4. Okay, this is length 4, and this is length 11. Those are big numbers, 4 and 11. So that's my rise and my run. So 4 over 11. Now, is this positive or negative? Can you see that from left to right? This is rising, so that makes it positive. So let's make sure it's positive. So that's it. So these are the 3 slopes that we have to work with. All right, we have this, and we have this, and we have -1/3. All right, ignoring the negative sign for a second, because remember, we were looking for ones that are opposite and reciprocal. Let's start with reciprocal. The reciprocal of 7 over 2 is 2 over 7. I don't see that. The reciprocal of 1/3 is 3 over 1, or 3. I don't see that. The reciprocal of 4 over 11 is 11 over 4. I don't see that. So none of these are even reciprocals of each other. So they're definitely not opposite and reciprocal. So therefore, none of these are perpendicular lines. Okay? So if you were just trying to guess, DE and FE sort of looked like maybe that was 90 degrees. But look, now you see DE and FE. it's really 7 over 2 and negative 1 over 3. Those are not reciprocals, okay? Now having said that, I feel like I should count DE again. Okay? I'm just going to count DE one more time, just in case I miscounted, because it's so close. I hate to be wrong. Okay. So this was 2, and this was 7. Yep. All right, so anyway, so we're going to say no as far as the answer to the final answer to the question. Okay? Is this a right triangle? No, because none of the slopes are opposite and reciprocal. So maybe I'll add that to our explanation. All right, last one. Show that KLM is an isosceles right triangle. Okay, well, let's take it one piece at a time. Let's start by showing that this is isosceles. Okay, we'll show it's isosceles by finding all of the lengths. Okay, so I'm going to break this up. Okay, so on this side, I'm going to prove isosceles. And then on this side, I'm going to prove right triangle. Okay, so in order to prove isosceles, I need to find the lengths. So I'm going to find the length of MK, for example. Okay, I need to find the length of KL. You know what, let me color coordinate this. So I've got MK, I've got KL, and I'm going to find the length of ML. All right, I need to find those three lengths. So let me start with MK. So to find the length of MK, I like to do the Pythagorean Theorem. So I'm going to make a right triangle with MK as the hypotenuse. Okay, so one side of the triangle is, let's see, 4. The other side of the triangle is 6. All right, so I've got 4 and 6. So I'm going to do my Pythagorean theorem. So I'm going to do 4 squared plus 6 squared is equal to c squared. All right, that is 16 plus 36 is equal to c squared. So that is 52 is equal to c squared. That means that MK is the square root of 52. All right, now I'm going to go back and find KL. So again, I'm going to make a right triangle that has KL as the hypotenuse. So this side is 4, and this side is 6. So I've got 4 and I've got 6. So I'm going to do the Pythagorean theorem. Wait, that's the same numbers I had last time. Okay, so I really don't need to do it again, right? If I did it again, if I did 4 squared plus 6 squared is equal to c squared, I'm just going to get 52 again. Okay, so fine, KL is again going to be 52. All right, now how about ML? All right, so here's a right triangle that has ML as the hypotenuse. This is 2, and this is 10. Yeah, 2 and 10. So I will do my Pythagorean theorem one more time. So I have 2 squared plus 10 squared is equal to c squared. So that's 4 plus 100 is equal to c squared. So that's 104 is equal to c squared. So that means ML is the square root of 104. So see how 2 of the sides are the same? I have 2 equal sides. That proves that this is isosceles. So I'm just going to write that down. Okay, so I'll say since we have 2 equal sides, it is isosceles. All right, so far we proved isosceles. Now it's time to prove that it's a right triangle. Now, just like I did on the last problem, I'm going to use slopes, all right, to prove that this is a right triangle. If it's a right triangle, 2 of the lines should be perpendicular. So that means their slopes should be opposite and reciprocal. Okay? So that means I need to decide what is the slope of MK. All right, so I'm just going to write slope MK. I need to decide what is the slope of KL. And what is the slope of ML? All right, what are these slopes? Well, slope is just rise over run. Remember that. Let's start with MK. Okay, so here's M, here's K. I need the rise and the run. All right, the rise is 4, and the run is 6. All right, rise over run. That's 4 over 6. So I have slope 4 over 6, which reduces down to 2 over 3. So there's my first slope. Also, notice that this rises. It's going uphill, so that's positive. So make sure that you have a positive slope. Now let's do KL. Okay, KL goes down 6 and over 4. So -6, that's the rise. And the run is positive 4. It goes down 6, right 4. Okay? And this reduces down to 3 over 2. Okay? And this is negative 3 over 2. Okay? I really could stop right now because I already see that these two are opposite and reciprocal. Okay? These are opposite and reciprocal. So that means that MK is perpendicular to KL. All right, so segment MK is perpendicular to segment KL. So triangle, what do they call it? Triangle KLM is a right triangle. All right, now, just for fun, I'm going to go ahead and find the slope of ML, just for the sake of completeness. Okay, here's the rise, and here's the run. So that's down 2 and right 10. So that's negative 2 over 10, which would be negative 1/5. All right, so now we've proven that this is a right triangle. So we proved that it was a right triangle, and we proved that it's isosceles. Together, that means it is an isosceles right triangle. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.